Hello, I'm Jerry, and we're back with another C Sharp training. During our previous training videos, we've learned how to move around Visual Studio. We've learned some basic data types. We've learned how to assign them. We've learned the first tool from .NET Framework, which is the console, which allows us to write stuff in our program on the console window, and also allows us to take really simple input from the user, which is just reading any key and not doing anything with it at the moment, but allows us to stop our program um, and allows us to display what is the result of our program. I told you I'll tell you how to organize our code and group pieces of code in smaller bits so that well, you can fold it. And this is one cool feature of Visual Studio. It's called folding. So you might have noticed these little minus boxes on the side, and when you click them, you actually fold a whole piece of code, so it's out of your way, and you can have more room, and well, yeah, it doesn't bother you much, because at some point your code will be long, and it will be really hard to navigate within the code. So it's really good practice to actually use that folding. And I didn't see that in any other programming languages, but actually this is part of C Sharp, and you can create something called regions, and this actually groups your code into smaller bits and allows you to fold those groups of code. So I'm just going to create a region. We start with a hash sign, and we say region. And yes, by default, when you put a hash sign, it goes to the left. Don't worry. Sometimes it will stay there. Sometimes it will go back where it should be. Well, yeah. And each region, you can just have a region without a name, I think. As far as I remember, it should be. Each region should have an ending. uh, I would call it ending bracket, but it's not really a bracket. Well, you just say end region, and then it gets highlighted in gray or whatever your Visual Studio highlights corresponding elements, right? And then you're able to fold this, right? But well, if you just had a whole bunch of regions, that would be well, hard to distinguish where is stuff. So each region can have a name. So I'll call this number one the basics, right? The basics, right? And then here will be simple data types, and other types, assignments, and printing to console. Right, something like this. Now when I fold this, you'll have this, well, let's call it title, right? And then you can, well, this code is still it will be compiled and it will be running and so on and so on. So this is one, well, quite nice. But it will still run, right? So if you create more code, then you might want to group this in some better groups. Now, because if I run this and then we'll be doing today some more stuff, then we'll still have the result of our previous program, and I just want to start clean, so I'll just go on to my Solution Explorer, right? Close this project and create a new one. So I click the solution, right click the solution and click add and a new project. Still be a console project, and now basic operations. I call this basic operations. So probably in the previous video you'll get that code, which is the basics, right? And you'll be able to play around with it. Don't worry, you won't be you won't mess up too much. And actually, I encourage you to play with the code and delete lines, add new ones, and well, just practice and see what results you get. So yeah, that's something that is really important for any computer scientist to actually try to do something on your own and then figure out what works best for you. So yeah. So let's jump in straight into what we want to do here. So I'm creating a new project which is called Basic Operations. Now it's been created for me, and I have a new default program CS. And what I need to do, because when I run the code now, I'll still have the previous program running because it's set as the startup project. So I need to change this one to the startup project now, because I want to work with this one now. And this one is folded, so we won't be using it, at least now. Okay, so I told you we'll be doing some basic operations. You already got to know string concatenation, right? So joining two strings together. So that's actually the first operation that you have. So concatenation of strings. Yep. So you have string first string. First string, right? And then you have string, right? Okay, and you can concatenate them. So you can say like console, right line, and then first string plus second string, right? And console, of course, read key. And then when we run it, we get this concatenated. Of course, there is no space between these two, so maybe let's add that. So if you want to add just pre-coded text here, you can also do that, right? So this is just a quick reminder from the previous course, right? So string concatenation of strings, you can say this is adding two strings. Maybe that's what you might imagine it, but it's not really adding. It's concatenating, so joining together, right? So that's actually the first operation that you learn, and that's on strings. And you can do this with characters as well. So single character, 8, right? Great, and you can add it here as well. And character. Like so. And then you actually concatenate this. Yeah, okay, I forgot a space, so let's just add that space. Like this. Okay, yeah. So now it looks like this. Okay, so that's actually the first operation, and you can actually do that as well. So final string is equal to, and let's just put that expression, because what this is called, so whenever you do some operations on variables, on values, on everything, this is called an expression. So an expression is, well, either, well, it's anything. It's not an instruction, plain instruction. It's something that results in a single value, right? So this is an expression because this results in a single value that can be assigned later on to a variable, or printed on the screen, or sent to somewhere, right? So yeah, so that's an expression, and then we assign this the value of this expression to another variable that we declared here, so the final string, and then we want to print it out on the console. So the result is the same again, but now we have this expression being assigned to a variable, and well, we might want to use that variable later on multiple times and not writing the expression all the time. So that's actually something useful, so that we get the value of the expression, not the expression itself. And also this is useful when the expression is more complex and takes longer time to be calculated by the computer. So that whenever you want to use a value and not recalculate it more than once, because you just like calculated it and then you just want to use that value, it's better to assign it to a variable, right, like I did here, and then reuse just the value instead of recalculating the expression. Depends on the thing that you want to do, because sometimes the value of the expression changes over time, and then you would probably need to recalculate it all the time. So it depends, but if you know the value of the expression will not change, or for example in your code you don't want the value actually to change, so you want it to remain the way you calculated it the first time, and then do some stuff with it, and you don't want it to change, then you should actually assign this value to a variable and then reuse it later on. Okay, so concatenation of strings. Now some mathematical operations. And before I jump into mathematical operations, I told you that there is a difference between the precision of those three types. So the float, f value, I'll just call it like this, f val. Yeah, like this, right? And there was a double, right? D val. Like this, and we had this decimal. I'm a bit, I have a sore throat, I'm sorry, something's wrong with my throat. Yep, and we want to print that on the console so that we can see the difference in the precision. So we'll just go right line, f value, like this, and copy that here, and then we have the d val, right, and then the decimal val as well. Okay, let's run the program, and for now you can see the representation of those values. And I don't remember if I said that. Yeah, I have the Polish settings in my regional settings. So the separator of the decimals is actually a comma and not a dot, but I hope it's not a problem for you. If it is, then maybe I'll change that later on. But for this video, it will be a comma. Okay, so for now there is no difference, but let's just think of holding a bigger value there. So let's just go 1, 2, 3, 4, 5, 6, this again, 1, 2, and then maybe one more. I'm not sure. We'll see in a second. Okay, I got an SMS. Maybe you heard that, maybe not. I hope this is enough, but we'll see in a second. 1, 2, 3. Okay, we need some more, as we can see, almost see that here. Let's just have some more. So 1, 2, 3, 4, 5, 6, and maybe this is enough. And let's see. Okay, yeah, that's enough. Yeah, that's enough. So now you can see that the float has more or less a half of precision. Oh, you wouldn't say it's a half precision because the decimal places take memory, and it's like half precision memory wise, but well, it's a smaller precision here, and then this is actually smaller precision than the decimal, right? And the decimal stops here and then doesn't have any more values, so these are actually not taking into account. And if I put a 6 here, oh, I need to stop the program, so yeah, if I put a 6 here, maybe not here, yeah, okay, yeah, it should be, can be here. If I put a 6 here, then it will round the last one. So there was a 9 here and there was an 8 here. So there was a 9 here, it changed to 0, and then this 8 changed to 9 because this resulted in a 10, so this is increased, and then instead of an 8 we have a 9, right? So it's rounded up, and that's the maximal precision we can get for our floating point values. So let's put the mathematical operations here, and then this difference in floating shucks point numbers precision. Difference in floating point number precision. Great. Okay, so now we'll just do some simple mathematical operations. So let's just get two ints, right? And we'll just call them A and B. Yeah, and I can go on declaring variables if they are of the same type, right? Then I can put a comma here, and then I can declare multiple variables, right, within one line, and they all be of the type int, right? Because I said I want to declare an int, and then I'm just saying like, okay, and these are the variable names. Now, as you can see, I didn't assign any values to them, but I can say like, okay, C is equal to 5 and E is equal to 3, and this is still okay. So this means that, okay, I'm not assigning anything to A while being while declaring it. I'm not assigning anything to B while declaring B, right? I'm assigning 5 to C while declaring C, nothing to D, and then assigning 3 to E while it is being declared. Yep, okay, but we'll just need two of them, so A and B. Let's just leave it. So we can declare multiple variables in one line. They all will be of the denoted type. Here it is int. Okay, I hope you understand that. So we'll be doing some really simple mathematical operations. So A will be equal to 2 and B will be equal to 3. I think this should be nice. And then we'll have another int, and I could declare it above, but I like to do it like this. So I have like some variables that are going to be used for some purposes. Then I usually put a comment here describing why I declare these variables and what are they for, and then the result is something else, and it's not used for calculations. It's like this will hold the result of my operations, and that's why I declare it on a separate line, right? So that's just I don't know the way I do it. You don't have to do it like this, but it makes the program a bit more readable, and well, it looks a bit nicer, right? Okay, so here result will be equal to A plus B, right? And then we'll print the result as well. Console, right line, addition, and then the result. Cool. Okay. So I print that out, and addition result is 5. And maybe, okay, let's just have this console, right line, A is equal to A, B is equal to B, and we'll have another thing here. I'll put s/l/n, so we have that mathematical operations and /r/n. Maybe put another one here. Yeah. Okay, so I hope you remember the /r/n special characters from the previous lessons. So these will just put a new line there. So we have this separated, so we have this concatenation, then we have the precision test, right? And then we have some mathematical operations. So A is equal to 2, B is equal to 3, and addition is equal to 5, right? And then we'll go on, and just let me pause, and I'll put all the other operations here, so the most simple ones, and then we'll be back in a sec. Okay, I'm back, and you can see oh, sorry. Now, this is magic of video editing. I'm sorry, forgot to add these here. Okay, so I've added the subtraction, multiplication, and division. Okay, I'm sorry. Here, I commented out division because I want to show you something cool here. And actually, division will be cool. So that's why I commented out, because well, I'll have a question and you'll figure out in a sec, and then I'll show you. Okay, so let's just run our program. So now A is 2, B is 3, so A plus B is 5, A minus B, so 2 minus 3, that's negative 1, right? And then if we multiply these, that's 6, right? Everything's correct. That's really nice. Cool. And now the division. So 2 over 3, that's like 0.6, and a lot of 6s there, right? That's the result that we think it would be. So let's uncomment that, and then let's run this. And whoa, our division is actually a 0. And we would suspect there will be like 0 point and a lot of 6s. Okay, let's try something else maybe. Maybe we put this here. Maybe it will be okay. And just to be sure, nah, won't put that. Not yet. It's still 0. Okay, now try to think why. Why the result is 0. You would suspect it would be like 0.6 and a lot of 6s, right? So 2 over 3, right? And the result is 0. Well, okay, here, if we did this here, right, then it might be a bit obvious that, okay, the result is of type int, right? So it can't hold anything else than an int. So maybe the precision does not allow to actually hold the decimal value. That's why it's just 0. Well, that's partially correct, yes. So if we change the type of the result, so let's just have this being a float now, right? And then if we run this, we still get a 0. So, okay, this is partially correct, but we still get a 0. And why is that? Well, how C# understands mathematics here is it takes the first variable, looks at the type, and then thinks like, it's an int. So the result is probably going to be an int. More or less it looks like this. So if we put something cool here, so we'll put a 1.0f in the beginning, and everything multiplied by 1 is still the same, then I think this should actually work. Yep. See? Yeah. So this is the simple way of solving this, and that's actually the simplest way. And let's just see. I'm not sure if this is going to work, but we'll get to know in a sec. If I put this here, will it work? I'm not sure, and I don't know the answer. It doesn't work. Okay, yeah. So this is what I suspected. So as I said, C# takes the first value of the operation, of the expression, and that value more or less denotes the resulting type. I'm not sure if this statement is correct, but that's how I understand that. And well, I might be wrong. I'm not a super specialist on C#. I'm just a guy that learned by himself, and I was just playing with C# for a long time, and I'm just going to give whatever I know, and well, then well, if I'm not a specialist, then I might be wrong. But still, I'm going to try to figure out, and whenever I don't know something, then I'll try to seek some knowledge about this, and then come back to you with some explanation or solution. So yeah, this is one way of dealing that. And if I actually get this back to an int, then I'll get an error here, because now the compiler already tried to figure out the result of this, and it thought like, okay, this whole thing is going to be a float. And if I go here back what we tried earlier, so times this, it's actually going to complain. The result is a float, but before we actually multiply that by a float, this is already an int, and the evaluation of this will give us a 0. So everything multiplied by a 0, yeah, well, it's a 0, right? So that's why, so it actually takes both sides. So it takes all the variables into account, yeah, obviously, and then figures out the type that would be the resulting type, and but the result of this is 0, because these both are ints. And if we think of the order of operations in mathematics, then multiplication and division have the same level of in the order of operations. This means that multiplication will be done first, because like if the level of the order is the same, then we go from left to right, right? And then the higher the order, that's the first operation that will be done, right? So here, if we're going from the left, then we say like, oh, okay, multiply a by 1.f, so by 1, which is a float. So now the value of a, which is 2, becomes a 2, but not a int 2, it becomes a float 2. And then divided by b, the result of that operation should be a float. So now we can hold the rest of the information, and then the result is okay. If we do it the other way around, right, so we put the 1.f on the other side, then the first operation that is being done is A divided by B, and the resulting type of that operation will be an int, and this int cannot hold the decimal part, so the result is just 0, right? And then 0 multiplied by 1 will be 0, and the resulting type will be a float. So that's how we evaluate this, well, simple operation, but something that might be confusing. And when you're doing your operations, even such simple ones, sometimes you might run into some problems, just because, well, you get into to problems with just the order of operations. And let me do a quick search so that I can find that table. There is a table on MSDN, or I don't remember where. Well, I'll find it. So I'll make a really quick break on the movie, and I'll find a table for you with the order of operations for C#. So give me a second. Okay, I found it. And it's here, and I added this in the comments so that you can have this link. And actually it's called the precedence and order of evaluation, whatever that might mean. You have a nice description here, and then you can see all the operations and well, their precedence and the level. So you can read this through. Now, I'm going to be, whenever I'll be doing some operations, I'm going to say which ones are more important than the others, and which ones are being done where, right? And yeah. And there is another thing, is like the direction. It's called associativity, but we'll just call it the direction of calculations. And most of them is like left to right. So if the operations on a certain level, for example, here you can see that multiplication, division, and modulo division, so they call it multiplicative, are left to right. So if you perform these operations, all these are the same level of in the order, right, in the precedence. So if you use those operations, then they will be performed from left to right. And for other operations, I'm trying to search for something that okay, none of these right to left operations would be a simple mathematical operation, so we'll jump back to that. But there are some that will be calculated right to left, and there is actually an explanation why these have to be calculated right to left and not left to right, because, well, when you see that, then you'll see like, oh, okay, yeah, that's why, and it actually seems logical, right? So yeah. Okay, so that's the order of operations. So you have this link here in code, so that you can check it out and read it through. And let me have a quick break, and the next video will continue with some more operations. So thanks for watching, and have a good day. Bye.